Let's do a tutorial for Positive Chemistry Unit 15. I'm going to start with acid naming. The simplest kind of acid has H on the front because all acids have H, because that's what acids do, is they give H+. So it has H on the front and one other element like that, in which case the name is hydro something acid, and it always ends in ic. So this is hydrofluoric acid. This is then hydrochloric acid. Well, anyway, you see the Cl? Hydrochloric acid. Oh, I got hypo. Whoops. Hydrochloric acid. There we go. So that is hydrobromic acid. And we're going to skip ahead and get something more complicated. There we go. All right. Notice that this is not one element attached to the H. That on your ion chart is nitrate. Go flip over your periodic table and look at the back. That is nitrate. And look at the acid naming box. If you get acid 8, nitrate, then it is nitric acid. Nitric acid. And that is sulfate on your ion chart. So it is sulfuric acid. Yes, the R comes back, and I realize that it sounds like it should be sulfic acid, but the R's come back for sulfuric and phosphoric because of reasons. That's why. So, whoops, it's sulfuric. There we go, acid. Here we go. Here's even more complicated, and you might want to hit pause and stuff and think about this. Look at your acid naming box and your ion naming box. So this is ClO2. And in our ion chart, we don't have ClO2, but we have ClO3. This is 1 oxygen fewer. So this is chlorite. And in your acid naming box, if you're using chlorite to make an acid, then it is chlorous acid. And we have CO3, that is carbonate, so it is carbonic acid. Here we have 2 elements coming together to make one kind of molecule or compound. So that is going to be a synthesis, meaning making. All it does is make. It doesn't break anything up. It doesn't have 2 pairs switching items and so forth. So it's synthesis. See that? And because 2 or more substances combine to form one compound. So that is B. That also is going to be synthesis, isn't it? In fact, I'm just going to go to the next one because it's too obvious. Okay, this has 1 chemical. The fact that there's 2 of them does not matter. And we broke it up. We probably cooked it real hard, put it over a flame, and it fell apart. So that is decomposition. Because 1 compound breaks down into 2 or more substances. Again, 1 compound fell apart into, in this case, 3 substances, but that's not the point that it's 3. It fell apart, and so it's decomposition. Here we go. Now we have this alcohol, and it burns with oxygen. So I bet one of our options here is combustion, and it is. So when you burn something with oxygen gas and you get carbon dioxide and water, that is combustion. It's fire. And a hydrocarbon combines with oxygen to form carbon dioxide and water. That's very much combustion. And that's going to be the same thing, so I'm going to go on. Here we have a different type. Notice what happened is that the Br took the place of the I. And the I's popped off, and because it's diatomic, check your ion chart, or check your periodic table, excuse me, look for the stars. I starred the diatomic elements. So they popped off, and then they combined in pairs. So the Brs replaced the I's, the bromines replaced the iodines, so that is a single replacement. And those are halogens. If you look at the column that Br and I are in, those are halogens. So I don't know that that's important, but anyway, if they want to be super picky, anyway, it's halogen replacement. Because 1 element was replaced. Here, the K replace the H. So that should be a single replacement, and I guess that is a hydrogen replacement. And one of the elements was replaced. That is D. I don't know that it's important to have the hydrogen replacement part, but there you go. Here's our more classic ones. All right. So in this case, the sodium left the S and it stuck onto the Cl. And the H left the Cl and it stuck onto the sulfur. Or you could view it the other way around, that the negatives were the ones that were trading partners. Anyway, you had trading partners. You had partners, and they traded like that, essentially. So the plus found a new minus in both cases. So that is a double replacement. Did it form a gas? It did. And you know, this is not a neutralization because acids have H's to give. This is a classic strong acid. This is not so strong, but it is still an acid, so it did not neutralize. Precipitation means that we formed a solid, and no, we formed aqueous, AQ, and a gas, G. So let's try gas formation, and we were right. Two compound swap partners, that's what we had. In this case, we have a classic base because OH loves to accept H plus because that would form water. Look, it formed water. This is OH plus another H, isn't it? And the K then stuck onto the NO3, at least so to speak. Just as a preview, no, it kind of didn't, because when ionic substances, our plus minus pairs here, dissolve their aqueous, when they're aqueous, they're not actually together, they're actually split apart. So did it replace the H? Kind of, but I think they want us to say it's a double replacement neutralization because we don't have any more acids. Water does not have an H to give in nearly the same amount. It does not count as an acid in our terminology. So it got neutralized. And we swapped partners, E. Here the lead took the place of the K, or the K took the place of the lead. So we have KNO3 and PbI2. And that will be a double replacement, but notice that solid, that means that we made what we call a precipitate. A new thing will fall out. And as I recall, that is a bright yellow, kind of weirdly enough, and that is E, as we said before, right? So a synthesis reaction means we're only going to make stuff. So two or more combine to form one compound. And hydrogen and sulfur react together. Okay. And what would you make? Take H and S, put them together. H likes to be +1. Hydrogen, sulfur likes to be -2. So you're going to need two of these. It's going to be like this: two H's and one S. So that's dihydrogen sulfide. Decomposition. One thing breaks down, that's A. If you break it down, you're going to get the lithium and the fluoride. So lithium is just a metal, it's just Li, but fluorine is diatomic, so it's going to be the F2. They didn't care about that. Lithide and fluorium is just cuckoo banana pants. I don't know what that is, but lithium and fluorine is what we want. Potassium bromide and chlorine. So that's potassium bromide, that's a 2 with chlorine. Is going to react in a single replacement reaction. Write it out. KBr plus Cl2, and then take the potassium and cut it loose of the bromide and put the chlorine on. So that's a single replacement. That is, one of them is replaced as D. And we get potassium bromine. It should be bromide. And oh, no, we get potassium chloride and bromine. There we go.